Next, we will understand about the concept called ozone hole. So, ozone hole. So, before understanding, okay, what do you mean by ozone hole? Hole is not literally mean there is a presence of hole, but it means depletion of ozone in stratosphere over the base, majorly over Antarctic region, because the depletion of ozone majorly happens at Antarctic rather than Arctic region. So now let's understand in detail about this ozone. So ozone is majorly of two types, tropical ozone and stratospheric ozone. So tropospheric ozone is a good ozone, we can say, we can say tropospheric ozone is a bad ozone, we can say stratospheric ozone is a good ozone, we can say, simply for our understanding. So tropical ozone is a short-lived greenhouse gas, and it is formed by the reaction of nitrous dioxide and hydrocarbons, whereas stratospheric ozone is formed by the combination of oxygen and free radical oxygen. This leads to formation of O3. So it is called as a regenerative reaction. So this is how it is formed. So O2 is there in the atmosphere, which will break down into ozone, and coming this ozone, when attached to another oxygen molecule, it forms O3. And similarly, this ozone also combining with another oxygen molecules forms ozone. So three times of ozone leads to three times of oxygen molecules leads to two twice of ozone molecules formation. So next is ozone depletion. What does ozone depletion mean? So we understand ozone hole. So ozone hole is nothing but ozone depletion. So ozone depletion we'll be seeing it in detail. So how we'll be measuring this ozone depletion is based on the Dobson unit. So for the ozone to get depleted, so there is substances called ozone depleting substances (ODS). So there are different ozone depleting substances. So these substances are responsible for depletion of ozone. So what are these? Chlorofluorocarbon, hydrochlorofluorocarbon, NO2, and halon, and carbon tetrachloride, and methyl bromide, and methyl chloroform. So and some also other, there may be other components. So understand all these ozone depleting substances majorly consist of fluorine, bromine, fluorine ions. So most majorly fluorine ions. So for let's take an example of chlorofluorocarbon. So these basically will be able to travel the long distance, and also this has biomagnification capacity. What is biomagnification? We have talked earlier. Also understand what is the difference between bio accumulation, bioconcentration, and biomagnification. So okay. So these are ozone depleting substances. And another thing what we need to understand is polar stratospheric clouds. So what are these polar stratospheric clouds? So basically these act as a platform for chlorine ions. So this is the Earth at a polar region. So let's consider currently as Arctic region. The same is also it is also same for the Antarctic region. So in polar stratospheric cloud, so let's say there is a cloud formation. So and also there is an ozone depleting substances are released. So let's say chlorine is released. So these chlorine ions gets attached to this polar stratospheric clouds. So basically we know there is a ozone present. We have chlorine getting from ozone depleting substances. So what happened whenever this chlorine is reacted with ozone, so this leads to formation of this ClO plus O2. So this reaction happens. So we can say simply like this: Cl plus ozone leads to ClO ion plus oxygen. So Cl we are getting it from ozone depleting substance. Ozone is already present at stratosphere. So by this, so as a one molecule free radical of O3 is getting attached to chlorine and oxygen is separated. So okay, so ClO is forming. So what here there is no O3 presence. So we can say that there is a depletion of O3 as uh, one of the oxygen molecule, free radical oxygen atom is getting attached with the chlorine. So there is no O3 present. Yeah. So what we are saying here, so polar stratospheric cloud. So these act as a platform for chlorine ions, yes, and combined with the regenerative O3 reaction. So see here, it is the same. Cl plus O3 leads to ClO plus O2. Means nascent oxygen is more attached towards the chlorine than O2. So so there is no more O3 presence in this reaction. There we can see there is no more O3. So it means ozone is decreasing. It is nothing but ozone is depleting. So it is this phenomenon is called as an ozone hole. So here ozone is decreasing, not like ozone is getting eliminated. So so here understand why ozone depletion is more in Antarctica. So earlier I told, so in southern hemisphere ozone depletion is more because the major reason is more stratospheric cloud is present in the Antarctica. So more stratospheric polar stratospheric cloud means there will be more ozone depletion because more number of CLOs will be formed.